All right, we are looking at 3.2 today. Our quiz over chapter 3 will be over the first 3 sections, so that'll be on Friday this week. We've got a review day on Thursday, so we'll cover another section tomorrow and then quiz on Friday. On Friday, we had talked about imaginary numbers. We talked about doing some different operations with imaginary numbers. And we'll see that a little bit in today's lesson. And today's not all about imaginaries, but we have to talk about imaginaries first because when we solve quadratics, one of our possible solutions is going to be an imaginary solution. And we're going to see that from time to time. So we're going to kind of go through all of the different ways to solve a quadratic equation today. If we have a function of a quadratic equation, we know it's a quadratic equation whenever it has x squared in it, okay? And so that immediately tells us we have a quadratic equation. And the first thing that we're always going to do is we're going to take that quadratic equation and set it equal to 0. And in a lot of cases, it'll already be set equal to 0. But if it's not, like for instance, if this constant is moved over here, then I got to move it over here, I got to set it equal to 0, and that's got to be the first step every single time, okay? And so we'll probably do some examples today where it's not like that right away and kind of show that to you. There are a lot of different ways that we can solve a quadratic, and you'll kind of remember a lot of these ways from years past. And it kind of depends on how the equation is written and to like which way is the best way. And so I'm going to kind of show you these. I'm going to talk about why this method might be better than this method or how we know what method to go to. But you will have some on your homework today where it'll say solve using any method you want. And then you'll also have some where it says solve by this particular method, just so you get some practice doing each of the methods. But then also being able to do it any way you want to, if that's the case. So, first up, I'm going to show you the 3 different possibilities. And I'm also going to show you how we could possibly use what we call the square root method. I'm going to kind of tie these together into one. We'll use graphing in other places as well. So the first one that I'm going to put up here x squared minus 25 equals 0. If I were to use the square root method, the thing that you'll notice here is there is no b value. This is considered my a value, which would be 1. This is my c value, but it's missing the x in the middle. So not all of these quadratics are going to have all 3 parts, a, b, and c. If it has all 3 parts, then we can use that to identify the a, b, and c. But if it's missing the b value, then I can do what we call the square root method, where I'm going to add 25 to both sides, and I'm going to take the square root. But when I take the square root, this is where you got to be a little bit careful. My answer here is a positive or a negative 5. There's actually 2 solutions, and we're going to find that out today, that on a lot of these problems, there will be 2 solutions as we solve it out. And the reason I say graphing is because I want to show you what this looks like on a graph. If I were to graph this one, and you could put this into your calculator. it's going to cross, it's a parabola. All of these are going to be parabolas because they're quadratics. It's going to cross the x-axis in two places. It's going to cross it at -5 and it's going to cross it at +5. And we did talk about that a little bit in chapter 2, where those are what we call our zeros. And the zeros are what we're looking for today. Where does it cross the x-axis? Those are our x-intercepts, and we also call them our zeros. And we'll also today call them our solutions. So there's a lot of different names that we can use to identify them, but the x-axis, the x-intercept are the pieces or the parts that we're looking for more than anything else. Okay, another possibility. Here's one reason why we use the square root method. If I graph this one, and I'm just going to graph it real quickly here, x squared plus 13. And so as I look at the graph on this one, it's still a parabola, but if I said, where does this cross the x-axis at? It never does, right? It does not cross the x-axis at any point in time. And so, like, going back to Algebra 1, we would have said there is no real solution here. There is no solution or no place where this crosses the x-axis. But because we have now talked about imaginaries on Friday, then you might say that this is no real, but we don't use that as our answer. We're not going to say no real solutions. Instead of no real solutions, then what that tells me is there's going to be two imaginary solutions. And we got to find out what those imaginary solutions are. So in order to do that here, we're going to take the equation. We're going to do the square root method. And here's where we're going to use some of those skills that we talked about on Friday. We're going to simplify this. And when we simplify the square root of -13, we break it up into -1 times 13. But this -1, we're going to pull out because the square root of -1 is really I. And so when we write our answer here, we would say plus or minus I radical 13. And so the unfortunate thing is that our calculator is not going to give us that solution. Our calculator will not give us the imaginary solution. So anytime we have an imaginary solution, or anytime the graph doesn't cross the x-axis, we're going to have another way of being able to determine what the actual solution is, and being able to get those two imaginary solutions out. And there are two of them because it's positive and negative. A positive I radical 13 and a negative I radical 13. So that's just a couple of things. That's why we use the square root method. That's how it ties into the graph that you see. So that's why I put both of those up there, graphing versus the square root method. We're kind of doing both things. The first instinct that we're going to have on a lot of these is to graph it. And I don't have any issues with that one bit. But if your graph doesn't cross the x-axis, then we're going to have a different way of being able to determine what that solution is. We can't just look at the graph like this one. We could have just looked at it and said, it crosses at +5 and -5, and that could have been my solution. And that might have been all I needed to do. But we can't do that for an imaginary solution. All right, the last one I'm going to talk about here for the different types anyway is one like this. Okay, and this one we cannot do the square root method on because it has a b value. But I put this in line with the other two because this is our third type of solution. And another thing that we're going to talk about here today is graphing it versus other methods. And what I'll show you here, first of all, is where this crosses the x-axis. But we're going to talk a little bit about factoring. We're going to go back and remember kind of all of our different factoring. Like, for instance, on x squared minus 25, I could have done dots on that one. I could have broke it up into x plus 5 and x minus 5, and then I could set both of those equal to 0. So we didn't really do DOPS here because I think it's a little bit easier to graph it and to solve using the square root method. This one's not DOPS, but this one is what we call a perfect square trinomial, because 9 is a perfect square. Or you could simply say what multiplies to get 9 and adds to get -6. And we can remember back to our factoring rules for trinomials. So what numbers multiply to get 9 and add to get -6? In this case, it's the same number, right? It's x minus 3 times x minus 3. If I foiled those two together, it would get me back to x squared minus 6x equals 9. But if these two are the same thing, then I'm only really going to get one solution. There's no reason to set that equal to 0 twice. So we're going to say x minus 3 equals 0, and we get x equals 3. If I were to graph this, and you could put this in the calculator if you want to, I'm just going to save some time here. It's still a parabola. That hasn't changed. But it's going to be a parabola that comes down, hits the x-axis at 3, and comes right back up. I call that a double root because it comes in and leaves from the same place. And we'll talk about the significance of double roots more as we go throughout college algebra. But for right now, we'll just say x equals 3. There's really only one answer here, x equals 3. Okay? And so those are our three possibilities. The parabola could cross the x-axis 2 times. It could cross it no place at all, or it could cross it or touch it in one place. Okay? And those are the three different scenarios that we could. Even if the parabola opens down, it could still only cross at most 2 times. So 2 would be the most that we're ever going to have anytime we have a quadratic equation. Those are our first two methods. We're going to talk about 4 or 5 different methods today. We can solve by graphing. That's a good old method to do. We can solve by using the square root method, but that only applies to, let's just kind of list these out. We can do the square root method. But in order to do that, there has to be no b value. We can always graph it. But sometimes the graph may or may not help us a whole lot. Okay, the third method we're going to talk about is factoring. And there's a lot of different kinds of factoring. So when I say there's only 3 or 4 methods, well, when I say solve by factoring, we could do DOPS. We could do our product and sum, which is one that I'll show you an example one like that here in a second. We could even do slide and divide, possibly. And I'll kind of remind you one of slide and divide. And so I'll kind of list those out. DOPS, product and sum. I call it the product and sum method. If you've had me in class before, you've probably heard that. If you haven't had me in class before, other teachers may not call it the product and sum, but I'll show you what I mean by product and sum. And then another type of factoring that we've done before is slide and divide. Those are probably the 3 most common. You could have a GCF involved, but typically with quadratics we really don't. So those would be the 3 most common that you might see with quadratics. Here, the fourth and final method is the quadratic formula. So that's kind of like our last option. If we have to do the quadratic formula, we'll do it, but I don't want to do it unless I really have to because it's kind of lengthy, right? So square root if we can. Graph it probably would be my first one even before the square root method, but the square root method's pretty simple to do. Factoring could be something I could get to depending on the type of polynomial I have. But like the last one that we did, factoring, none of these other options were available, so we had to get to the quadratic formula. So let's look at one that is what I call the product and the sum method. And no matter what you call it, this is a method that we've all seen before. Okay, it's probably the most common type of factoring that we do when we have a trinomial like this. The reason I call it the product and the sum is the C value is our product. The middle number is our sum. And product means multiply. So I need two numbers that multiply to get me -7, and they add up to be 6. Okay, and so like I said, I call it product and sum, and whatever anybody calls it, it's the same idea. Two numbers that multiply to get the C value and add to get 6. One way that you might have learned how to do it is to do like a little T-chart, list out all the things that go into -27. And what you'll find out is that like sometimes these numbers will pop out at you, okay? If you're really good, like really good number sense and can come up with those numbers quickly, sometimes you got to kind of go through and there might be a lot of different things that go into -27. So in this case, the two numbers that we're looking for are 9 and -3, okay? And whether those pop out to you right away or not. But there's not a lot of things that go into 27. 9 and 3, that's it, right? I could also do -9 and +3, but they have to add up to be 6. So these are what we call our two factors of that. But when we write our answer here, first of all, we have to write those as factors. These are the two factors that when multiplied together, when I FOIL these together, it would get me back to this, right? And so we got to write them as factors first. These are not our solutions. These are our factors. That's what you got to understand. Because now I got to take my two factors and set them both equal to 0. And we would get -9 and +3. And those are our two solutions. The one thing that I'm going to keep going back to here is if we graphed this, these would be the two places it crosses the x-axis. You can verify that. You can graph it and you can see, does it cross at -9.3? And I'll tell you this right now. Like if I were to give you this problem and I'd say solve using any method you want, probably the easiest, quickest way is to just graph it and say -9 and 3 are the two places it crosses. And I don't really have an issue with that, but there are times where they're not going to be nice whole numbers like they are here. And so we won't always be able to use graphing to get everything we want. And using product and sum shows us how we can get there another way as well. There wasn't anything in front of x squared. So if there's no number in front of x squared, that tells me I can do product and sum. When I do have a number in front of this page, the other type of factoring I'm going to show you here is slide and divide. It's been a little while since we've done a slide and divide problem. You're not always going to have x's. Here I put some m's in there just to show you that it could be a different variable. It could be x's, it could be m's, it could be b, it could be whatever variable. A variable really doesn't matter. It's still a quadratic equation. If we have a coefficient in front of n squared that is bigger than 1, like on the last one we just did, x squared, like here I have a 5. So this 5 right here tells me I have to do slide and divide. And it's very similar to product and sum. But your product here is going to be -10. We're going to multiply the lead number times c. So we're going to take 5 times -2. That's going to be what we call our product. And our sum is 3. Same idea. We got to find two numbers that multiply to get -10 and add to get 3. And so that would be a +5 and a -2. Okay, but we can't just write our answer as n plus 5 and n minus 2. because we have a number in front. N plus 5 and n minus 2 would not FOIL to get me back to where we started. But we are going to start with that. Okay, so we call it slide and divide because we're going to do two things. We're going to divide first, actually, and we're going to divide by the leading coefficient. So the number that's in front is the number that we are going to divide by. If it reduces, we're going to reduce it. If it doesn't reduce, then we got to write our answer a little bit different way. So 5 over 5 right here would just reduce to be 1. So this would become n plus 1. If it does not reduce or simplify, then we're going to slide the bottom number over in front of the m, and this would become 5m minus 2. Those are our two factors. If we FOILed these two together, it would get me back to here. And that's how you could kind of check if you wanted to check, and I know that's going to take a little bit more time, but just to understand where does this come from, does this really work or not? We could FOIL it to see. We're going to set both of these factors equal to 0. So m would be negative 1. And then over here, we're going to add 2. We're going to divide by 5. And we get 2 over 5. Those are our two solutions. Okay, a couple of things real quick here before we move on. These are my two solutions. And so just like any other equation that we've ever talked about, maybe it's a linear equation. These are the two numbers I can plug back into this equation, and that would make it equal 0. Do we have to check it? No. But if you're ever unsure if this is your answer or not, or if, let's say, I had a multiple choice question and I can't really figure it out, I can't solve it, and I'm struggling with it, I could take the possibilities that I have, I could plug it back in for m, and I could see if it really does make 0 or not. Okay? So just understand that those are the two solutions that make this equation equal 0. And that's how you could check it, if you wanted to check it. The other thing I wanted to point out here, and I want to keep coming back to this, 2/5 is the same as like 0.4, so it's like between 0 and 1. Negative 1 is on the x-axis. If I were to graph this, your graph is going to look something similar to this. It's going to cross the x-axis at negative 1, and it's going to cross the x-axis at 2/5. And you could verify that, right? You could put that into your calculator and see what you get. This would be the same as 0.4, 2/5. Okay. So I think it's really important to understand the link between these. Okay, there's lots of different ways that we can get to our solution, but we're just trying to talk about why do we want this method versus this method, and where would we use this method at. Okay, the good news is we're not going to complete the square. That's another method we could do. You might remember completing the square from Algebra 2. It's kind of a nasty method, and we hardly ever use it, and so that's another thing that we are not going to do. So that's one good thing, is we're going to forget about completing the square. Okay, if I give you a problem like this. Hey, first up, the first thing that we have to do, and all the ones that I've given you up to this point have already been in that format, but if it's not set equal to 0, that's got to be our first step, no matter what, okay? And so I'm going to subtract 7 from both sides. And that gets us to here. Okay, and one of the things that they're going to ask you to do in some cases is they're going to ask you to write the exact value of your solution. And so using your calculator is a great tool, okay? But if I were to graph this one, and I'm going to go ahead and put it in my calculator just to show you what we got, and you guys can do it at the same time as me, just to kind of make sure that you know how to type all this in. The methods that we've done up to this point. In this case, because we have a number in front of 3, negative 21 is my product, 2 is my sum, but there's no numbers that make that work, okay? So we can't factor this because that would be slide and divide, and we can't do slide and divide here, okay? We can't do the square root method that we did early on because we have a b value here. So the square root method is out, factoring is out, and we could graph it, but graphing doesn't give us the exact value, so then we think, well, how am I going to get to the exact value? Well, the good, the bad, however you guys want to look at it, is we have a way to get there that we've done before. And one thing that we can do anytime we have a quadratic equation is we can use what to solve it? Quadratic formula. Good old quadratic formula, right? And I'm sure you guys can all just rip this off like you saw it yesterday, right? No, Danica? Don't even want to try?
Don't even know what it is.
Oh, you do too. If you see it, you're going to be like, I know what it is. Okay, quadratic formula. X equals the opposite of B plus or minus the square root of b squared minus 4ac all over 2a. We've all seen that, right? Yes? So you do know what it is?
I just wish I did.
That might be the case. I get you. So this is A, B, and C. Those are your A, B, and C values, okay? We're going to take the A, B, and C values and we're going to plug it into this equation. Okay, this we read it as the opposite of B. I don't want to read it as the negative B because if you do that, then more often than not, you think that always has to be a negative, but that's not the case. If this was negative, this will be positive. If this was positive, this is going to be negative, okay? It's the opposite of B. B is 2, so the opposite of 2 would be negative 2. Okay, one thing that I like to do is this right here is B squared. I just go ahead and square it. If it's positive 2, it becomes 4. If it's negative 2, it becomes 4. So I square whatever B is. So 2 squared is 4. I'm just going to go ahead and square it. Minus 4, okay? This 4 always stays. It's always part of the formula, never changes. And then A is 3. And C is negative 7. All over 2 times A. Okay. So the first thing we do is just kind of input all of our numbers into the formula. And now we're going to go about simplifying this. So we're going to go negative 2 plus or minus. I always simplify under the radical here first. And you got to really watch your signs here. 4 times 3 is 12. And some people say, is this a negative 4 or is this a minus 4? It really doesn't matter, but you can't use it twice. So I kind of leave it alone for right now. What some people even maybe do is they put 4 in parentheses itself. It's kind of up to how you want to handle it. 4 times 3 is 12. 12 times negative 7. This would become 4 minus negative 84. All over 6. 4 minus negative 84 is really 4 plus 84, which is 88, all over 6. Okay, then we're going to simplify this. I have to break down radical 88. This is kind of like what we talked about on Friday when we break down the radicals. I'm going to look for pairs. First thing, anything that goes into 88. So you could even do something like 11 times 8. You could do anything that goes into 88, whatever you want. 2 and 44. Okay, I'm going to use 11 and 8. 11 is prime. 8 would break up into 2 times 4, and 4 would break up into 2 times 2, which means we have a pair of 2's. So when I simplify this, the pair of 2's are going to come out, and then we have an extra 2 and an 11. So these two numbers, because they don't pair up, are going to multiply back together. 2 times 11 would be 22. All over 6. Okay, the last thing that we can do to simplify this, we can't do anything with the 22 because it's underneath the radical. But these 2's and the 6, we can take a 2 out of all of them. They all have a 2 in common. So I can reduce this to be that. And you don't necessarily have to put the 1 in front here. You can just leave it as radical 22 because the 1's assumed to be there if it's nothing there. So you could just write negative 1 plus or minus the square root of 22 over 3. Okay, this is what we refer to as the exact value. The decimal answer that we got a few minutes ago, if we were to put this into our calculator, that would still equate to that decimal answer, okay? But this is just the exact value way of writing your answer. Good news is we don't have to do the quadratic formula very often. There's a lot of different, easier ways to get there most of the time. It's going to be like the last thing on my list that I'm going to do, okay? Usually if you see the words exact value, we're probably going to have to do the quadratic formula. Not always, okay? But more often than not, if you see exact value, we're probably going to end up having to do the quadratic formula, okay? If I wanted to write the decimal answers, I could do that instead here. And we will have some problems like that on our quiz where it'll just say round to the nearest hundredth and you can give me the decimal answers and you don't have to go through all of this. Okay, one more problem we're going to do. So that's kind of okay, if I ask you to solve using any method you want, okay, I can pick any of the methods that we've solved with. When you see the ones that say solve using any method you want, first of all, square root method is out because we have a b value, right? I could graph it, okay? If I did graph this one, so that tells me, and we could try to factor it, okay? But if I say what multiplies to get 8 and adds to get 5, none of that, nothing works, okay? So we can't factor it, we can't do any of those methods that we talked about, so that means this is another quadratic equation. And our answers are imaginary, so we also know that in the end, we should get an answer that has an I in it, okay? So let's see what this one looks like. Negative 5 plus or minus b squared would be 25 minus 4 times 1 times 8. All over 2 times 1. Four times 1 times 8 is 32. So 25 minus 32 is negative 7 all over 2. When I simplify the square root of -7, this is -1 times 7, like we saw on Friday. I'm going to bring the -1 out. There's where our I comes into play. And there's nothing here that we can simplify. -5 and 2 don't simplify. 7's under the radical, so that doesn't really matter anyway. So this is, once again, what we call our exact answer. We just leave it like that. All right. Lots of fun today, right? Solving quadratics. No better way to start Monday on a Tuesday. Okay, we're going to do 5 through 80 by 5s. We're going to skip number 60 because number 60 says solved by, or it actually asks for the discriminant, and we're not going to worry about the discriminant. On number 30, you can use any method. Don't use, I think that is a completing the square one, and we did not talk about completing the square, so you don't need to worry about that. And on number 35, you're going to use the quadratic formula. Thank you, Mr. Frecking.